So today we are going to see this new chapter from your industrial pharmacy, that is nothing but the aerosols. So again, aerosol is a very important chapter for your GPAT Niper and all kind of exams. We have seen your pre-formulation, then tablet and capsules. This industrial pharmacy. So one more, we also seen excipient. There we have seen two sessions on excipient. We have seen the pre-formulation, tablet, capsule. Then okay, one more session will be there on excipients, and after that we will see micro encapsulation. Before that, okay, let's start with the aerosol and try to complete aerosol today itself. We'll try to complete it. Now, what do you mean by aerosols? Again, a kind of dosage form, pharmaceutical dosage form, in which drug along with the propellants they are enclosed in the pressurized container. So aerosols are nothing but the pressurized dosage form. It is a pressurized package system that depends on the power of compressed gas or compressed liquid to propel the drug. So it is a pressurized package system in which drug is packed along with the propellants or liquefied gases or simply liquids. Okay? Propellant, liquid or liquefied gases. Drug is dispensed or drug is delivered. Drug is dispensed as a fine mist or foam or simply a spray through these aerosols. So aerosols are nothing but the pressurized package and a system that depends on the power of compressed gases or compressed liquid to expel the content, including your drug. That is a aerosol. Now there are different component aerosol package. What are the component of aerosol package? So you might have seen this aerosol. आपका जो simple body spray भी होता है, that is also aerosol system, and it will work exactly in a similar way as that of the pharmaceutical aerosols. So same thing is there, same phenomenon is there. Just in the deodorant you have aroma, and in the pharmaceutical aerosol you have medicament. That's it. So rest of the system is same. Now component of aerosol package, very important. So you have different components. So in the aerosol package you will find propellants, then container for aerosol, then valve, then actuator, then product concentrate or blend. So product concentrate or blend, that is the different in case of your other aerosol system and pharmaceutical aerosol system. In the pharmaceutical aerosol system or pharmaceutical aerosols, you have medicament. Medicament. Okay, it is a product concentrate having medicament, and other aerosols will not have medicament. Other will have different. For example, your body spray will have aroma, etc., etc. Now, this is known as a product container. Okay, this is known as a product container, and this is known as a aerosol valve. This is known as a aerosol valve. In the aerosol valve, again there are different components like actuator, steam, gasket, then cap, mounting cap, ferrula, then spring, etc., etc. We are going to see in the detail, don't worry. But what happens, so drug along with the propellants or drug along with the compressed gases, so it is in this package where it is filled in under the pressure. When you press this actuator, so what happens? Pressure over here is decreased. Pressure over here is decreased, and whatever liquid is there in this tube, so the in this container, that liquid will move towards there, and then liquid is converted into gas. How? Because a simple phenomenon is there. When you apply pressure on a gas, or when you cool the gas, if you decrease the temperature of gas, or if you compress the gas, or if you apply the pressure on gas, so gaseous state is converted into liquid state. So reverse phenomena occurs over here. So when you relieve the pressure, so liquid will convert into gas, and that will come out the container in the form of spray. So that is the simple phenomenon over here. So we are going to see it. So this is a container. This part is known as a container. Now this part is known as a valve. This part is known as a valve. In this valve only you have different parts we are going to see. This one is known as a deep tube. This one is known as a deep tube. It is also a part of valve only. So if you magnify that valve, you will find such kind of structure. So actuator, then steam, then steam cascade, housing or body, spring mounting, then mounting cap, then dip tube. So these are the component of valve only. So you might have got some idea. So aerosols are nothing but the pressurized package containing drug. So that depends on the power of compressed gases to expel the drug. We will see in the detail regarding this. Now aerosols are pressurized packages as I told you. Now component also we have seen propellants. In the aerosol you have propellant, then container, then valve, then actuator and product concentrate or blend. Now advantages of aerosol over other dosage form. कि advantages क्या क्या हो सकते हैं इसके? So what will be the advantages? Why we are moving to the aerosols? Or why we have tablet, we have capsule, we have other dosage form? Then why aerosols? Why there is need of aerosols? So there are certain advantages of aerosol over other dosage form. It depends. It depends on the need. So advantages of aerosol. So again we'll see. So first, okay, the product can be removed from the container without any contamination. So what you have to do in case of aerosol, you just have to apply pressure on the actuator. The drug or the dosage form or the blend of drug will come out without contamination. So there is no physical contact between the drug formulation and your hands. So product can be removed without any contamination. Increased stability. There is increased stability in case of aerosols because it is due to in the container there is a prevention of entry of oxygen and water. So oxygen water container के अंदर नहीं जा रहा है. That's why stability उनका बढ़ रहा है. So in case of aerosol there is a less chance of contamination and also stability is enhanced due to prevention of entry of your moisture and water. Then sterility is also maintained if you are dealing with the sterile dosage. So you are not touching or you are not in a direct contact with the product. So that's why sterility is also maintained. Then stability is enhanced. You can remove the product without any contamination. Okay. Then drug delivery is there at a site of action. So where you want to apply? Suppose for example, if you got a strain or sprain, अगर आपको कोई मसल में स्ट्रेन आ गया स्ट्रेन आ गया तो आप क्या करते हो इमीडिएटली डाइक्लोफेनाक का स्प्रे आता है वहां पे वो स्प्रे करते हो. So you can apply on that particular area, right? So delivery of a drug to a site of action is okay. Delivery of drug to the site of action directly okay is desired okay in the form of spray or either steam or breaking foam or stable foam. Now aerosol may be dispensed as a different form. तो जब aerosol जब dispense होगा जब product बाहर आएगा तो product वो बाहर कैसे कैसे आ सकता है. So dispense product may be like your spray. It may be like a spray, fine mist of droplets, and stream. Okay, it may be stream, quick baking foam. इनिशियली वो फोम हो जाएगा आपके यहाँ पे लेकिन वो ब्रेक इजीली हो जाएगा. सो क्विक ब्रेकिंग फोम और स्टेबल फोम. सो दीज आर द different characteristic or different type of your spray. So जब spray आएगा आपको delivery of drug to a site of action directly in desired form. So if you want to spray that product as a liquid, then liquid spray is there or fine mist, then stream, then peak breaking foam is also available or stable foam is also available. So you can apply a drug to a site of action in a desired form. Okay, in a desired form. Then again, the irritation at the site of application as compared to other dosage form, less irritation. Suppose you are applying, for example, you are applying a cream. If you are applying a counter irritant solution, if you are applying lotion, तो वहाँ पे आपको अप्लाई करना पड़ेगा जाके भरना पड़ेगा. So it may cause irritation to your skin. In case of aerosol, you just have to hold the container at a okay at a site and you just have to spray. So there is a little bit irritation as compared to other like your ointment, then counter irritant lotion, etc. Am I audible? So as compared to counter irritant lotions, creams, ointments, in case of aerosol, there is a less irritation. Am I audible? Rapid onset of action. Rapid onset of action and no first pass effect. So in case of aerosol, there is no first pass effect. Mostly aerosols they are applied on a locally on skin or few aerosols they are available to inhale. So through lungs, okay, through nasal cavity or through mouth cavity. So rapid onset of action is there and no phosphate, and then prevention of destruction of drug from GIT fluids. So you are in the aerosol, you are delivering the drug at the site of action either on locally, or you are delivering the drug in a your respiratory tract. So it will bypass the phosphate. Onset of action will be rapid, and it will prevent a drug to be destroyed by GIT fluids. So that is another advantage. Alternative dosage form, those drugs which are showing a complicated pharmacokinetics or erratic pharmacokinetics upon oral or parenteral use. जो ड्रग अच्छे से स्मूथली एब्सॉर्ब नहीं हुए, इरेटिक उनका काइनेटिक्स है, मतलब उनका काइनेटिक्स स्मूथ नहीं है, प्रॉपर्ली एब्सॉर्प्शन नहीं, डिस्ट्रीब्यूशन नहीं. So in such kind of drugs, if you formulate such kind of drug in the aerosol, so alternative dosage form will be there. So alternative dosage form to the drugs which are having irritant kinetics, right? Tamper proof system, ease of application, convenience of application. So in case of aerosol, tamper proof system is there. So aerosol container देखो आप बहुत ही strong होता है, बहुत ही है ना. So it is a tamper proof system. There is ease of application, convenience of application in case of aerosol. These are the few advantages of aerosol. So first four advantages are important. So first we'll see the propellants from the aerosol. Propellants, very important question इसके ऊपर आता है. Now what is the role of propellants? So propellants, they are responsible for the developing a pressure within a system. They are responsible for developing the proper pressure in the container so that the product will be expelled. So propellants are responsible for the development of proper pressure in the container to expel, to deliver the product when valve is open. When valve is closed, at that time propellants, they are in a liquid form, they will not expel the product. But when you open the valve, if you press the valve, so what happens? If you press the valve, there is a relieving of pressure over there, relieving of pressure, and that's why liquid will become gas. So when valve is open, the propellants will develop a proper pressure within a container and expel the product, and aids the atomization. Atomization means what? Conversion of liquid into spray. Conversion of liquid into spray. It is atomization. So they propellants are responsible for the developing a proper pressure in the container when valve is open, and they will also help, they will also aid the atomization of liquid or blend. Again, they also help to produce a foam production of the product. That is the role of your propellant in the container. प्रोपेलेंट का रोल क्या है भाई कि प्रॉपरली प्रेशर डेवलप होना चाहिए उसमें. व्हेन यू प्रेस वाल्व, वाल्व ओपन करेंगे जब आप, तो प्रॉपर प्रेशर डेवलप होगा, और जो लिक्विड कॉन्सेंट्रेट है आपके ड्रग के साथ में, वो लिक्विड कॉन्सेंट्रेट एक्सपेल होगा इन द फॉर्म ऑफ आइदर मिस्ट, और इन द फॉर्म ऑफ स्प्रे, और इन द फॉर्म ऑफ फोम. प्रोपेलेंट आर क्लासिफाइड इनटू थ्री टाइप. इसके ऊपर दो बार क्वेश्चन आ चुका है. Propellants in the aerosols, propellants in the aerosol, they are classified into three types depending upon their use. इसका use क्या है भाई, मतलब if it is used for inhalation purpose, so different type of propellant, right? So propellants for oral and inhalation use, that is the first class. Propellants for topical use, that is the second class. So propellants for oral and inhalation use. So remember, fluorinated hydrocarbons, fluorinated hydrocarbons, they are most commonly used for the inhalation aerosols. क्वेश्चन आता है chlorofluorocarbons, fluorinated hydrocarbons, or simply hydrocarbons. So they are fluorinated. Remember, fluorinated hydrocarbons like propellant 11, propellant 12, propellant 114. So it is a name of propellants. 114, propellant 12, propellant 11. They are the fluorinated hydrocarbons. So hydrocarbons में क्या है? Fluorine add है. Fluorinated hydrocarbons, they are most commonly used for inhalation aerosol. यहाँ पे याद रखना है inhalation aerosol, oral and inhalation aerosol. क्वेश्चन आ चुका है, क्वेश्चन आ चुका है. So fluorinated hydrocarbons, they are propellants for oral and inhalational aerosols. Right now, again, propellant. Okay, propellants for topical use. So propellants for topical use is nothing but the hydrocarbons. So like hydrocarbons like propane, isobutane, butane, propane, butane, isobutane. Again इसके ऊपर भी एक बार क्वेश्चन, दो बार क्वेश्चन आ चुका है. Which kind of propellants they are used for topical aerosol formulation? So hydrocarbons like propane, butane, isobutane. So remember, hydrocarbons like propane, butane, isobutane, they are used for the topical aerosols. Okay? So inhalational aerosols, oral aerosols, fluorinated hydrocarbons for inhalational aerosols. For topical aerosol, hydrocarbons like propane, butane, and isobutane. Am I audible to you? Particularly, okay, the particularly the fluorinated hydrocarbons, those propellants which are known as a fluorinated hydrocarbons, they have one formula. इसके ऊपर भी क्वेश्चन आ चुके हैं. What is the formula? Okay. Now all these propellants, they are designated by letters. Like you can see over here, propellant 114, propellant 12, propellant 11. Now they are designated with the number. Why? They are designated only fluorinated hydrocarbons, chlorofluorocarbons. Okay, so remember chlorofluorocarbons. So they are designated with the numbers. Now they have formula. What is the formula? Cn minus one, H n plus one, and F. Cn minus one, H n plus one, ये एक साथ में होता है n plus one and then F. Cn minus one क्या है? So in the chlorofluorocarbons, so number of carbon minus one is the number of carbon. कि यो पर्टिकुलर मॉलिक्यूलर फॉर्मूला है वो प्रोपेलेंट का, उसमें नंबर ऑफ कार्बन कितने हैं, कैसे रहेंगे, कैसे आइडेंटिफाई करेंगे? नंबर ऑफ कार्बन माइनस वन, तो उतने नंबर ऑफ कार्बन है उसमें. नंबर ऑफ हाइड्रोजन कितने रहेंगे उसमें? नंबर ऑफ ओके हाइड्रोजन कितने रहेंगे? नंबर ऑफ हाइड्रोजन प्लस वन, है ना. तो मतलब अगर कोई प्रोपेलेंट है आपका, वो प्रोपेलेंट में नंबर ऑफ कार्बन कितने हैं, हाइड्रोजन कितने हैं, फ्लोरीन आइटम कितने हैं, वो कैसे आप डिसाइड कर सकते हो? उसके मॉलिक्यूलर फॉर्मूला तो है आपके पास, है ना, रिएक्शन है. सो उसमें डिसाइड करने के लिए यू हैव टू अप्लाई दिस फॉर्मूला. Cn-1, number of carbon will be number of carbon minus 1, number of hydrogen will be number of hydrogen plus 1, and F means fluorine, you know, F means fluorine. And also number of chlorine atom also can be calculated. Okay, we'll see it later. So remember the formula Cn-1, n plus 1, Cn-1, H n plus 1, and F. That is the formula for, है ना. फॉर्मूला के ऊपर भी क्वेश्चन आ चुका है. Now few chemical or few propellants with their chemical name. So propellant 11. What is propellant 11? Propellant 11 is nothing but a trichloromonofluoromethane. Trichloromonofluoromethane. So remember name of these propellants. क्वेश्चन इसके ऊपर आ चुके हैं कि कौन सा प्रोपेलेंट का नाम क्या है. मतलब ये प्रोपेलेंट है तो उसका नाम क्या है. Propellant 112 नाम क्या है, Propellant 113 नाम क्या है. So remember Propellant 11 is nothing but the trichloromonofluoromethane. Trichloromonofluoromethane. This is the Propellant 11. Propellant 12 क्या है? Propellant 12 is nothing but the difluoromethane. Difluoromethane. That is Propellant 12. What is propellant 114? Dichlorotetrafluoroethane. Dichlorotetrafluoroethane. So इसके ऊपर आपको क्वेश्चन आ चुके हैं. इसमें कुछ रॉकेट साइंस नहीं है, आपको नाम ही रखना पड़ेगा, याद रखना. ट्राइक्लोरोमोनोफ्लोरोमीथेन प्रोपेलेंट 11. प्रोपेलेंट 12 डाइफ्लोरोethane. प्रोपेलेंट 114 that is nothing but the dichlorotetrafluoroethane. Propellant 115 chloropentafluoroethane. Then propellant 152A difluoroethane. Butane is known as a propellant A17. Isobutane is known as a propellant A31. Propane is known as a propellant A108. So all propellants, they have designated with the numerical designations are there. They used to ask questions. जैसे यहाँ पे propellant 12 के ऊपर एक बार क्वेश्चन आ चुका है, propellant 11 के ऊपर क्वेश्चन आ चुका है. What is propellant 12? difluoromethanes. इसमें एक है according to the formula, ये अपन बाद में देखेंगे. लास्ट में क्या है यहाँ पे मीथेन. मीथेन ये आ गया है मोनोफ्लोरो मीन्स मोनो मतलब एक, मीथेन मतलब एक, डाइक्लोरो डाइफ्लोरो, डाइ डाइ डाइक्लोरो डाइफ्लोरो, डाइफ्लोरो है दो, दो डाइफ्लोरो, इथेन यहाँ पे क्या है, इथेन है, इथेन का 2 कार्बन एटम, डाइक्लोरो टेट्राफ्लोरो इथेन, डाइक्लोरो टेट्राफ्लोरो टेट्राफ्लोरो इथेन, 4 है ना, 4 यहाँ पे क्या है, तो है ना 4 फ्लोरीन एटम है, लाइक दिस, आप ऐसा भी याद रख सकते हो उसको। दीज आर द कॉमनली यूज्ड प्रोपेलेंट्स, उसका फॉर्मूला अपन बाद में देखेंगे, फॉर्मूला प्लस एक्सप्लेन करूंगा मैं आपको पूरा है। ब्लेंड्स ऑफ these propellants, blend मतलब क्या, मिक्सचर, mixture of these propellants are also available for a particular vapor pressure of the propellant to obtain a particular vapor pressure of propellant in the aerosol. So these are the most commonly used propellants. So out of that बाकी भी है, आप भी देखेंगे अपन। ट्राइक्लोरो मोनोफ्लोरोमीथेन is known as the propellant 11, डाइक्लोरो डाइफ्लोरोमीथेन propellant 12, ट्राइक्लोरोटेट्राफ्लोरोमीथेन और टेट्राफ्लोरोइथेन known as a propellant 114, क्लोरोपेंटाफ्लोरोमीथेन propellant 115, dichloroethane propellant 152A, butane propellant A17, butane isobutane propellant A13, propane propellant A108, right? Now blends of these propellants they are also available. Blend मतलब क्या है, जैसे combination of the propellant 11 propellant 12 30s to 70, propellant 12 propellant 11 50 like that. So such kind of mixtures or blends are also available to get an adequate vapor pressure and all that. Now vapor pressure of mixture of propellants. Now if there is a mixture of propellants, now in that case vapor pressure of mixture of propellant is given by Dalton's law. Vapor pressure of mixture is given by Dalton's law. You know. So what is vapor pressure? Pressure exerted by a liquid which is in a equilibrium with the atmospheric pressure. The pressure exerted by liquid which is a equilibrium with the, okay, which is in a equilibrium with the atmospheric pressure known as a vapor pressure. Now if you mix two propellants, so this propellant A will have a different vapor pressure, propellant B will have a different vapor pressure. The final mixture, what is the vapor pressure of final mixture? The vapor pressure of final mixture is nothing but the vapor pressure of individual, okay, it is a sum of the individual vapor pressures of the component. So according to Dalton's law, the vapor pressure of final mixture is nothing but the sum of the vapor pressure of individual component present in the mixture. इसको बोलते हैं अपन Dalton's law. So Dalton's law of vapor pressure is nothing but the total vapor pressure of mixture of a propellants is equal to the sum of the vapor pressure of individual propellants. That's it. That is the Dalton law. And also it is vapor pressure is also determined by Raoult's law. Raoult's law. और इसके ऊपर GPAT 2023 में भी क्वेश्चन आ चुका है. Raoult's law. What is Raoult's law? Raoult's law state that decrease in the vapor pressure. Raoult's law state that decrease in the vapor pressure of a, okay, decrease in the vapor pressure of a liquid upon addition of third substance, that is a solid. So decrease in the vapor pressure of liquid upon addition of third substance depends on the mole fraction of that solute. Mole fraction of that solute. That is a Raoult's law. So Raoult's law is different. Dalton's law is different. You have to understand. We'll see it again. So, are you getting my voice properly? Are you getting my voice? Dalton's law क्या होता है? It is nothing but it is a vapor. Dalton's law is the law for measuring the vapor pressure of mixture of propellants. Now according to this law, the total vapor pressure of a mixture is nothing but the sum of the individual vapor pressure of the component. That is the Dalton's law. Now what is the Raoult's law? Raoult's law indicate that, or it state that decrease in the vapor pressure of a mixture upon addition of a solid, that depends on the mole fraction of solute. That is nothing but the Raoult's law. Raoult's law के ऊपर क्वेश्चन आया है GPAT 2023. Okay? Now different propellants over here you can see. So propellants class and chemical name. Propellants class and chemical name. पहला class कौन सा है? Chlorofluorocarbons known as the CFCs. Chlorofluorocarbons known as the CFCs. So in that you have different propellants. Chlorofluorocarbons में कौन सा है? जैसे for example यहाँ पे कौन सा है? ट्राइक्लोरो मोनोफ्लोरोमीथेन. trichloromonofluoromethane CCl3F. It is known as a propellant 11. Propellant 11. Second, dichloro-difluoromethane. Dichloro-difluoromethane. Dichloro-difluoroethane. Dichloro-difluoroethane. So it is known as CCl2F2 and it is known as a propellant 12. थर्ड होता है आपका डाइक्लोरो टेट्राफ्लोरोइथेन. सो CCl2 CClF2. सो प्रोपेलेंट 114. इसका नाम ही याद रखना है ट्राई क्लोरोमोनोफ्लोरोमीथेन प्रोपेलेंट 11. डाइक्लोरो डाइफ्लोरोइथेन प्रोपेलेंट 12. डाइक्लोरो टेट्राफ्लोरोइथेन प्रोपेलेंट 1112. Now, these are the chlorofluorocarbons, right? CFCs, chlorofluorocarbons or CFCs. Second type of propellant होता है आपका हाइड्रोफ्लोरोकार्बन्स. हाइड्रोक्लोरोफ्लोरोकार्बन्स है ना, ये क्या है? क्लोरोफ्लोरोकार्बन्स, ये CFCs. यहाँ पे क्या है? हाइड्रोक्लोरोफ्लोरोकार्बन्स. They are known as HCFCs. Hydrochlorofluorocarbons, right? So in that, for example, पहला कौन सा है? डाइफ्लोरोइथेन. So difluoromethane, CH3CHF2, difluoromethane. So propellant 152A. Then hydrofluorocarbons, HCFCs. पहला क्लास है क्लोरोफ्लोरोकार्बन्स, दूसरा क्लास है हाइड्रोक्लोरोफ्लोरोकार्बन्स, तीसरा क्लास है आपका हाइड्रोफ्लोरोकार्बन्स. इसमें क्या है? टेट्राफ्लोरोइथेन. सो टेट्राफ्लोरो CH3 CH2F. So propellant 134A. नेक्स्ट है आपका हेप्टाफ्लोरोप्रोपेन. सो इसका डेजिग्नेशन है 227, propellant 227. नाउ नेक्स्ट क्लास होता है आपका propellant का हाइड्रोकार्बन्स, सिंपली हाइड्रोकार्बन्स. सो दे आर यूज्ड फॉर टॉपिकल, याद रखना है आपको. सो हाइड्रोकार्बन्स दे आर यूज्ड फॉर टॉपिकल स्प्रे. These chlorofluorocarbons and hydrochlorofluorocarbons they are used for oral and inhalation aerosol. Oral and inhalation aerosol. अब इसमें आता है ब्यूटेन, known as a propellant, A17. उसके बाद में आइसोब्यूटेन, propellant A31. propane is known as a A108. then hydrocarbon ethers. next class है आपका hydrocarbon ethers. so in that dimethyl ether. then compressed gases होता है, compressed gases another class propellant का. कार्बन डाइऑक्साइड, नाइट्रोजन, है ना, नाइट्रिक ऑक्साइड, नाइट्रस ऑक्साइड. सो compressed gases. सो डिफरेंट क्लासेस ऑफ योर प्रोपेलेंट्स, है ना. पहला क्लास है क्लोरोफ्लोरोकार्बन, है ना, उसमें ट्राइक्लोरोमोनोफ्लोरोमीथेन प्रोपेलेंट 11, है ना. डाइक्लोरो डाइफ्लोरोमीथेन प्रोपेलेंट 12. डाइक्लोरो टेट्राफ्लोरोइथेन प्रोपेलेंट 114, है ना. ये क्लास सेकंड क्लास आता है आपका हाइड्रोक्लोरो फ्लोरोकार्बन्स HCFCs. पहला है CFCs. CFC में डाइफ्लोरोमीथेन प्रोपेलेंट 152A. हाइड्रोफ्लोरो, ओके. उसके बाद में नेक्स्ट क्लास आता है हाइड्रोफ्लोरोकार्बन HFCs, हाइड्रोफ्लोरोकार्बन्स. उसमें टेट्राफ्लोरोइथेन, इट इज प्रोपेलेंट 134A. हेप्टाफ्लोरो प्रोपेलेंट 2271. उसके बाद में नेक्स्ट क्लास आता है हाइड्रोकार्बन्स. सो ब्यूटेन, आइसोब्यूटेन, प्रोपेन, है ना. तो ब्यूटेन इज नोन एज अ प्रोपेलेंट A117, आइसोब्यूटेन A31 एंड प्रोपेन 108. उसके बाद में तो क्लासेस कितने हैं देखो, क्लासेस याद है आपको, याद रखना है क्लासेस. अगेन एक बार रिवाइज करता हूँ. पहला क्लास है आपका क्लोरोफ्लोरोकार्बन्स CFCs, है ना. उसमें प्रोपेलेंट 11 आता है. इट इज अ ट्राइक्लोरो मोनोफ्लोरोमीथेन प्रोपेलेंट 11. उसमें डाइक्लोरोडाइफ्लोरोमीथेन प्रोपेलेंट 12. नेक्स्ट होता है डाइक्लोरोटेट्राफ्लोरो, है ना, इथेन प्रोपेलेंट 114. दूसरा क्लास कौन सा है आपका? हाइड्रोफ्लोरोकार्बन्स. पहला था क्लोरोफ्लोरोकार्बन CFCs, दूसरा है हाइड्रोक्लोरोफ्लोरोकार्बन HCFCs. डाइफ्लोरोइथेन, उसमें डाइफ्लोरोइथेन प्रोपेलेंट 152A. नेक्स्ट क्लास है आपका हाइड्रोफ्लोरोकार्बन्स HFCs, CFCs, CFCs and HFCs. तो इसमें एग्जांपल है टेट्राफ्लोरोइथेन प्रोपेलेंट 131 134A, हेप्टाफ्लोरोप्रोपेन प्रोपेलेंट 227. नेक्स्ट क्लास था आपका हाइड्रोकार्बन्स. हाइड्रोकार्बन्स मीन सिंपल हाइड्रोकार्बन आएंगे ब्यूटेन, आइसोब्यूटेन एंड प्रोपेन. ब्यूटेन इज नोन एज अ प्रोपेलेंट A17. क्वेश्चन आती है इसके ऊपर इसलिए 2-3 बार ले रहा हूँ. आइसोब्यूटेन प्रोपेलेंट A31, प्रोपेन प्रोपेलेंट A108. तो इसमें याद रखना है कि जो टॉपिकल वाले प्रिपरेशन, टॉपिकल वाले यूज करने वाले जो हाइड्रोकार्बन है उनका उनके कैपिटल लेटर दिया है उनको, है ना. those topical, those propellants which are used in topical, they are having capital letters like A17, A31, A108. तो इसके ऊपर आपको याद रखना है कि सबसे पहले आता है ब्यूटेन, है ना, उसके बाद में आइसोब्यूटेन, उसके बाद में प्रोपेन. तो ब्यूटेन को है A17, आइसोब्यूटेन को है A31 एंड प्रोपेन को है A108. बाद में हाइड्रोकार्बन ईथर्स. नेक्स्ट क्लास होता है आपका हाइड्रोकार्बन ईथर्स. इसमें है डाई मिथाइल ईथर. देन लास्ट क्लास होता है कंप्रेस्ड गैसेस. कंप्रेस्ड कार्बन डाइऑक्साइड, है ना, नाइट्रस ऑक्साइड एंड नाइट्रोजन. सो दीज आर द डिफरेंट क्लासेस ऑफ योर प्रोपेलेंट्स. उसमें और भी इंफॉर्मेशन दिया है, जैसे फॉर एग्जांपल सोलिबिलिटी, है ना, सोलिबिलिटी इन वाटर एट 77 Fahrenheit डिग्री. So solubility of that propellant in the water at this temperature. उसके बाद में वेपर प्रेशर भी दिया है. वेपर प्रेशर एट 70 Fahrenheit and 130 Fahrenheit respectively. उसके बाद में उसका बॉइलिंग पॉइंट दिया है ना, Fahrenheit में, डिग्री सेल्सियस में, इंटेंसिटी दिया है. बट ये सारी चीज़ें आपके लिए कोई नहीं पूछेगा, इतना ईजी नहीं है, ये नहीं पूछेगा. बट ये जो तीन पहले कॉलम है ये इंपॉर्टेंट है. सो नेम एंड देयर डेजिग्नेशन, propellant name and their numerical designation. That part is important, that's why. Are you getting my voice properly? Now blends or mixture of above propellants, they are also available for a vapor pressure. Mixture of propellant can be. Now blends of these propellants, they are also available. But if you are making a blend, if you are making a mixture, then you have to determine the vapor pressure. Now vapor pressure of that mixture can be determined by Dalton's law. Dalton's law. तो आपको याद रखना, क्वेश्चन आता है वेपर, which law is related with the vapor pressure? Dalton's law. What is it? And depression of vapor pressure by addition of another compound, that is determined by Raoult's law. Dalton's law मतलब क्या है? It is related with the total vapor pressure of mixture. Dalton's law, by using Dalton's law you can measure a total vapor pressure of a system of a mixture. By using Raoult's law you can measure a depression of vapor pressure by addition of solid. Now Dalton's law क्या है? Total vapor pressure in any system is equal to the sum of individual partial pressure of the various component. तो Dalton law मतलब क्या है? उसका कहना यह है कि vapor pressure of a mixture of an individual component, okay, vapor pressure of mixture is equal to the partial vapor pressure exerted by each component. Simply it is a sum of the partial pressure of the component. So total vapor pressure of mixture is equal to the sum of the partial vapor pressure of individual component. That's it. Dalton's law. Next is the Raoult's law. So Raoult's law is nothing but the lowering of vapor pressure. और GPAT 23 में ऐसे ही क्वेश्चन आएगा. Lowering of vapor pressure of a liquid by addition of another substance. The law related is Raoult's law. So Raoult's law is related with the lowering of vapor pressure or depression of vapor pressure of a liquid by addition of some solid. Depression of vapor pressure of solvent upon addition of solute is proportional to the mole fraction of the solute molecule in the solution. Law क्या कहता है देखो, depression of vapor pressure of solvent upon addition of solute is proportional to the mole fraction of solute in the molecule in the solution. Mole fraction of the molecule in the solution. कि अगर वाटर है आपके पास, वाटर का वेपर प्रेशर मान लीजिए XYZ है, अगर उसमें आपने शुगर ऐड कर दिया तो उसका वेपर प्रेशर कम हो जाएगा. सो डिप्रेशन ऑफ वेपर प्रेशर ऑफ वाटर दैट डिपेंड्स ऑन द नंबर ऑफ मोल्स ऑफ सोल्यूट व्हिच इज एडेड, दैट इज गिवन बाय राउल्ट्स लॉ. Dalton's law क्या कहता है कि टोटल वेपर प्रेशर ऑफ अ सिस्टम इज इक्वल टू द पार्शियल वेपर प्रेशर एक्सर्टेड बाय इंडिविजुअल कंपोनेंट. सम ऑफ द पार्शियल वेपर प्रेशर exerted by individual compound. तो डिफरेंस क्या है दो लॉ में, इंपॉर्टेंट है, क्वेश्चन आता है इसके ऊपर, आ चुके हैं ऑलरेडी. नाउ फ्लोरीनेटेड हाइड्रोकार्बन्स दे आर मोस्टली यूज्ड फॉर इनहेलेशन propellants. ठीक है, याद रखना है. फ्लोरीनेटेड हाइड्रोकार्बन्स दे आर मोस्टली यूज्ड फॉर inhalational aerosol or inhalational or systemic or oral or inhalational aerosol. Now for topical aerosol, hydrocarbons and hydrocarbon ether and compressed gases they are used. टॉपिकल के लिए हाइड्रोकार्बन यूज करते हैं और हाइड्रोकार्बन ईथर यूज करते हैं और कॉम्प्रेस्ड गैसेस यूज करते हैं. तो याद रखना है टॉपिकल के लिए क्या यूज करते हैं, इनहेलेशन के लिए क्या यूज करते हैं. क्वेश्चन आ चुका है, टॉपिकल के ऊपर 2 बार आ चुके हैं, इनहेलेशन के बाद 1 बार आ चुके हैं. एज कम्पेयर टू द क्लोरीनेटेड हाइड्रोकार्बन्स, एज कम्पेयर टू द क्लोरीनेटेड सिंपल हाइड्रोकार्बन जो होते हैं दे आर inflammable. Simple hydrocarbons they are inflammable as compared to chlorinated hydrocarbons. They are less toxic, they are less dense, they are more economic, more stable, more soluble. So जो hydrocarbons होते हैं simple hydrocarbons as compared to chlorofluorocarbons they are more inflammable. मतलब ब्यूटेन अगर लेंगे तो वो जल्दी आग पकड़ लेगा, है ना. So hydrocarbons they are more inflammable as compared to chlorinated hydrocarbons, but they are less toxic than the chlorinated hydrocarbon. They are less denser, density कम होता है उसका, more economic, easy मतलब cost effective होता है, more soluble and having more chemical stability. So this is a comparison between these two. Now compressed gases will have a little expansion power and will produce fairly a wet spray. Compressed gas होता है, expansion power कम होता है. When you release the pressure at the time gas should expand, liquid should expand. तो पहले तो लिक्विड फेज में है, compressed है, तो जब प्रेशर रिलीव करेंगे तो उन्होंने गैसेस स्टेट में आना चाहिए इमीडिएटली, मतलब एक्सपांशन होना चाहिए. So compressed gases will have little expansion power and will produce a fairly wet spray and less stable form as compared to liquefied gases, and they are used for hair preparation, ointments, dental cream, aqueous germicidal creams, and antiseptic aerosols. Am I audible to you? Audible आएगा? Yes or no? Now types of propellants. As I told you, we have seen in the chart types of propellants: chlorofluorocarbons, CFC, hydrochlorofluorocarbons, that is a HCFCs, and then hydrofluorocarbons, HFCs. Chlorofluorocarbon known as CFCs, hydrochlorofluorocarbons known as HCFCs, and hydrofluorocarbons known as HFCs. They are commonly used. Okay. All purified propellants are identified by by numerical designation. Propellants जो होते हैं propellants they are named by 3 digit. Propellants they are named by 3 digit. Like for example 000. जो 3 digit है वो क्या है? So every propellant they are designated with a 3 digit number. Okay. Now what are these? Propellants are named by 3 digit number. They are designated by 3 digit number. For example 000. तो पहला 0 क्या है, दूसरा 0 क्या है, तीसरा 0 है. पहले 0 में कार्बन, दूसरा 0 में हाइड्रोजन, तीसरे में फ्लोरीन होता है. ठीक है, तो ये फर्स्ट डिजिट जो पहला रहेगा, फर्स्ट 0, पहला डिजिट जो रहेगा, फर्स्ट डिजिट, that is nothing but the first digit is nothing but the number 1 less than total carbon in the molecule. So first digit is nothing but the number of carbon, which is nothing but the number of carbon present in the molecule minus 1. So first digit is a number of 1 less than total carbon in the molecule. So C minus 1. That's why वो फॉर्मूला भी यहाँ पे आ जाएगा आपको, C minus 1. सेकंड डिजिट क्या है? Second digit is number of hydrogen in the molecule plus 1. Okay. So Cn minus 1. Why? So first digit indicate the number of carbon minus 1. Okay. Less than 1. Number of carbon less by 1. First digit will indicate the number of carbons only. But पहला digit जो होता है propellant का वो number of carbon के लिए है, लेकिन number of carbon कितने रहेंगे उसमें? Total number of carbon in the molecule minus 1. ठीक है, उतने नंबर ऑफ कार्बन रहेंगे, वो इंडिकेट करता है. सेकंड नंबर क्या इंडिकेट करता है? सेकंड नंबर इंडिकेट द नंबर ऑफ हाइड्रोजन प्लस 1. नंबर ऑफ हाइड्रोजन कितने है उसमें, उसमें +1, सो CN-1 HN+1 एंड थर्ड डिजिट जो होता है दैट इंडिकेट द नंबर ऑफ फ्लोरीन एटम, third digit indicate the number of fluorine in the molecule, third digit indicate the number of fluorine in the molecule. Are you getting it, are you getting this or not? So propellants they are designated by the 3 digit number. पहला नंबर क्या है भाई, CN-1 C-1, सेकंड नंबर क्या है H+1, थर्ड नंबर क्या है फ्लोरीन एटम. So propellants are named by 3 digit numbers like 000. First digit is nothing but the number of carbons -1, total number of carbons in the molecule -1. Second digit indicate the number of hydrogens in the molecule +1. Third digit indicate the represent the number of fluorine in the molecule. जो chlorofluorocarbons है, so these formulae or these rules are applicable only for them. So they are named up by 3 digit number. First digit is nothing but the which will indicate the carbon atom. Now how many carbon atom, the total number of carbon atom present in the molecule -1. Now second digit will indicate the hydrogen, so what is it, number of hydrogen atom +1. Third digit indicate the number of fluorine atom, that is fluorine. Okay. Now fluorine also can be calculated, number of fluorine atom also can be calculated subtracting or by minusing sum of the fluorine atom and hydrogen atom from the total number of atom that can be added or that can be added to saturate the carbon chain, है ना. मतलब नंबर ऑफ क्लोरीन कैसे कैलकुलेट कर सकते हो आप, तो नंबर ऑफ क्लोरीन एटम कैन बी कैलकुलेटेड बाय सब्सट्रैक्टिंग, है ना, माइनस करना है, क्या माइनस करना है, नंबर ऑफ फ्लोरीन एटम प्लस नंबर ऑफ हाइड्रोजन एटम, number of fluorine atom minus number of hydrogen atom are added to saturate the molecule. That's it. That's how you can calculate the fluorine atom also. तो याद रखना है. If isomers are there, if ना two if isomers are there, for example ये आप देखो ना, एक ही है, इसका molecular formula सेम ही है, इनका molecular formula सेम ही है, arrangement is there. Okay? This is one is a more symmetric molecule. This one is a more symmetric. This one is a less symmetric. So if isomers are there, most symmetrical one is indicated by single small alphabet. Okay, single, and after that A B C, you know, is on. So if isomers are there, most symmetrical जो है उसको it is indicated by single small alphabet like A B C, as it become more symmetrical, as it become more symmetrical. साइक्लिक कंपाउंड अगर है दे आर डिनोटेड बाय सी, स्मॉल सी बिफोर द नंबर, मतलब फॉर एग्जांपल C111, मतलब ये जो 111 प्रोपेलेंट है दैट इज साइक्लिक C11. एग्जांपल डाइक्लोरोटेट्राफ्लोरोइथेन, डाइक्लोरोटेट्राफ्लोरोइथेन, इसका मॉलिक्यूलर फार्मूला क्या है, डाइक्लोरोटेट्राफ्लोरोइथेन. एग्जांपल लिया यहाँ पे वन डाइक्लोरोटेट्राफ्लोरोइथेन. So C2Cl2F4. Now number of carbons are 2. इसमें number of carbon कितने थे? So first digit क्या आएगा इसका C-1, that is a 1. C-1 दो carbon है, so C-1 एक पाएगा, है ना, 2 - 1 एक, first digit will be 1, है ना. A molecule has not any hydrogen molecule. इसमें कोई hydrogen molecule नहीं है, मतलब hydrogen molecule नहीं है मतलब क्या है, 0 है. तो दूसरा digit क्या है आपका, नंबर ऑफ हाइड्रोजन +1, है ना. सो नंबर ऑफ हाइड्रोजन किसमें कितने, इसमें 0 +1 कितना 1 हो गया. सो सेकंड नंबर क्या आएगा 1. पहला तो नंबर ऑफ कार्बन है ना, फॉर्मूला याद रखना CN-1 है ना, HN+1 यानी फ्लोरीन, ये सब फॉर्मूला है. CN-1 मतलब नंबर ऑफ कार्बन -1, नंबर ऑफ कार्बन कितने कितने इसमें 2 -1 कितना हो गया 1. सो 1 पहला डिजिट आएगा 1. दूसरा डिजिट कितना आएगा, दूसरे डिजिट के लिए फॉर्मूला के अकॉर्डिंगली क्या है, सो अकॉर्डिंग टू द फॉर्मूला CN-1 HN+1 नंबर ऑफ हाइड्रोजन +1. इसमें नंबर ऑफ हाइड्रोजन कितना है, डाइक्लोरोटेट्राफ्लोरोइथेन में एक भी नहीं है, मतलब 0 है. 0 + 1 1. सेकंड डिजिट नंबर आल्सो भी 1. सो पहले तो एक हो गया कार्बन का, दूसरा हो गया एक, है ना. इट आल्सो हैज अ 4 क्लोरीन एटम. इसमें कितने एटम है, 4 क्लोरीन एटम. So third digit कितना आएगा? So it is nothing but the 114. This propellant is known as a 114. 114. Molecular. Okay. So how to number the propellants? Are you getting or not? समझ रहे हैं आपको? How to number the propellants? 114. This dichlorotetrafluoroethane is known as a 114. Why? Because it has a 2 carbon. So according to the formula CN-1 मतलब first digit आएगा आपका 1. फॉर्मूला नंबर ऑफ हाइड्रोजन प्लस 1. इसमें हाइड्रोजन कितने 0 प्लस 1 आएगा. सेकंड डिजिट आएगा 1. एंड नंबर ऑफ फ्लोरीन कितने इसमें 4 है. थर्ड डिजिट आएगा 4. सो इट इज नोन एज 1 1 1. अगर फ्लोरीन नहीं है तो फिर 0 आएगा. फ्लोरीन नहीं तो 0 आएगा. डाइक्लोरो इथेन जैसे डाइक्लोरो इथेन आएगा तो 11 प्रोपेलेंट 11 लाइक दिस. Molecule also has a 2 chlorine atom which can be placed in a 2 different way to get a isomers isomeric form. इस isomeric form आएंगे. Now isomer 1 is having more symmetry than second, so designated as a propellant 114 and propellant 114A respectively. तो जो मॉलिक्यूल को ज़्यादा सिमेट्री है उसको उसको लेटर नहीं देना है, लेकिन उसके बाद में सिमेट्री कम हो रही है उसको A, उसके बाद में कम है P, C, like that. That's why this propellant is known as a 114. Okay, this one is known as a 114 and this one is known as a 114A. 114A like this. इतना लेने का रीजन ये है कि प्रोपेलेंट के ऊपर क्वेश्चन आता है. अपने we already seen these propellants. So chlorofluorocarbons, then hydrofluorocarbons, then we have seen the hydrofluorocarbons HFCs, CFCs, yes CFCs, HFCs, then आपका आता है हाइड्रोकार्बन्स HCs, उसके बाद में आता है हाइड्रोकार्बन ईथर्स HEs, उसके बाद में आता है compressed gases. These are the classes of propellant used in the aerosols. नेक्स्ट कंटेनर फॉर एरोसोल. क्वेश्चन आ चुका है. कंटेनर फॉर एरोसोल should withstand with the high pressure. Container for aerosol should withstand with the high pressure. And what is the pressure? तो as it is क्वेश्चन आ चुका है जीपैट में. ये containers used in the aerosol should withstand with the high pressure as much as 140 to 180 psig at 130 Fahrenheit. 130 Fahrenheit डिग्रीज पे ये जो कंटेनर होता है एरोसोल के लिए वो दैट शुड विथस्टैंड विद दिस प्रेशर. इसके ऊपर एज इट इज क्वेश्चन आ चुका है. कंटेनर फॉर एरोसोल शुड विथस्टैंड विद द हाई प्रेशर एज मच एज 140 to 180 psig at 130 Fahrenheit. 130 Fahrenheit. Now bursting pressure is must not be less than 300 psig. bursting pressure मतलब क्या? 300 psig से कम प्रेशर में ये कंटेनर टूटना नहीं चाहिए. bursting pressure means the pressure required to break the container, so it should be not less than 300 psig. 300 psig के कम नहीं होना चाहिए, उससे ज़्यादा ही होना चाहिए bursting pressure. And manufacturer of aerosol container must test one bottle out of each lot of 20,000 bottle for bursting point. ये क्या रखना है? Aerosol container manufacturer should test one bottle out of each 20,000 bottles for bursting point. Now containers in case of aerosol they are made from either either metals like tin plate, then aluminum, then glass is also there. So tin plate container किससे बनता है? tin plate container, tin plated steel which are nothing but the tin is electroplated from both sides of the steel plate, so to withstand with the high pressure. Again ये जो steel container होते हैं, so in case of steel container you have very limited fabrication types. So steel container they are having limited fabrication is मतलब हर एक शेप का आप बना नहीं सकते हो स्टील का. So tin plate containers are also. In case of tin plate container there might be corrosion. So if liquid is there, water is there, if ethanol is there in the aerosol formulation, it can corrode, it can degrade the steel. So corrosion is also another problem. Aluminum containers are also used. So mostly these type of containers they are used. Aluminum container, they are most widely used container in case of aerosol preparation. So they are used to okay, they are used to manufacture the seamless aerosol container. They are used to manufacture the seamless aerosol container. Aluminum containers are also corroded by few propellants. So they are corroded by pure water and pure ethanol and combination of ethanol and propellant 11. सबसे पहले आपका आता है स्टील कंटेनर. स्टील मतलब क्या? टीन प्लेटेड स्टील. तो टीन प्लेटेड स्टील, टीन इलेक्ट्रोप्लेटेड किया जाता है. टीन is electroplated over the steel and tin plated containers are used for aerosols. Second, aluminum containers are also used, right? Aluminum containers are also used. Stainless steel container, okay? Steel, okay? Tin plated stainless steel, aluminum container. So aluminum container के साथ में क्या है? They are most widely used, but they also can give various kind of shapes. They also withstand with the high pressure. They are used to put the seamless aerosol container, but they are also corroded by pure water and pure ethanol. Also corroded by corrosion करते हैं, degradation करता है, erosion होता है. किसे? Combination of ethanol and propellant 11, because this combination will produce a hydrogen acetyl chloride. हाइड्रोजन एसिटाइल क्लोराइड एक बाय प्रोडक्ट बनता है if you combine ethanol and propellant 11. Now hydrogen acetyl chloride, then aluminum chloride, and also one product known as a propellant 21 and other corrosive product. तो क्या है, जब एल्यूमिनियम एज अ कंटेनर यूज कर रहे हो आप, so you have to avoid pure water, pure ethanol or combination of ethanol and propellant 11. Then stainless steel container, they are having limited use because of their cost and production problem, because they are not easy to fabricate, used for inhalation aerosols only. Last में था glass container. Glass container also is suitable and compatible because there is no corrosion of the glass and greater degree of freedom in the designing of shape of aerosol. तो ये containers, remember, must withstand with the high pressure, that is 180 psig, 140 to 180 psig at 130. क्वेश्चन इसके ऊपर आ चुका है. आर यू गेटिंग और नॉट? समझ रहा है आपको? नाउ वाल्व्स ओके. वाल्व, व्हाट इज द रोल ऑफ वाल्व? Valve is nothing but the a part of your aerosol system which helps to dispense the product. Okay, so valve must be capable for delivering the content in a desired form and it should be approved by FDA. जो valve है, valve should be able to deliver the content in a required form. So if you want a fine spray, if you want a mist, if you want a foam spray, if you want to a solid steam, so a valve should be capable of dispensing or delivering the content in the desired form and that must be approved by US FDA. Pharmaceutical aerosols में dispensed as a spray. Pharmaceutical aerosol में एक तो आपको spray dispense कर सकते हैं और foam या फिर solid steam, और may not be required to control the dosage. Dosage control भी requirement कभी कभी लगता है, कभी कभी नहीं लगता. In case of meter dose, you need a dosage control. But normal other you don't need a dosage control. अगर कोई वोलिन स्प्रे लेके आता है तो ऐसा तो नहीं कैलकुलेट है कि नहीं 25 mg स्प्रे करना है. So in that also there are two type of valve: continuous spray valve, continuous spray valve, continuous spray valve. Now in this case it consists of actuator, steam, gasket. In continuous spray valve के भी parts होते हैं. There are different parts of continuous spray valve like steam, actuator, gasket. Gasket is made from a butyl rubber or bunayan rubber or neoprene rubber. इसके ऊपर भी 3-4 बार क्वेश्चन आ चुका है. In case of aerosol, gasket is made from butyl rubber or bunayan rubber or neoprene rubber. ये रबर के टाइप होते हैं. In case of aerosols, spring is made from a stainless steel. Mounting cap or ferrula is made from aluminum or brass. Used with the glass bottle. ये glass bottle के साथ में यूज करते हैं. कौन से? Continuous spray valve. Or for small aluminum tubes. And for small aluminum tubes or single or double epoxy or anal coating is there to raise the corrosion. Housing is also there. Housing, then valve body is there. These are the parts of your valve. Valve के part होता है. जैसे है ना। वॉल के पार्ट कौन से आपका, है ना, ये सब क्या है, वॉल के पार्ट, एक्चुएटर, है ना, स्टीम, गास्केट, है ना। देन उसके बाद में आपका हाउसिंग और वॉल बॉडी। हाउसिंग को ही वॉल बॉडी बोलते हैं, दैट इज मेड फ्रॉम आइदर नायलॉन और डर्लिंग, nylon or knitting. Now deep tube, in case of aerosol, deep tube is made from, in case of deep aerosol, deep tube is made from, इसके ऊपर 4 बार क्वेश्चन आए। सो इन केस ऑफ aerosol, deep tube is made from polyethylene और polypropylene which is more rigid। तो polypropylene ज़्यादा rigid होता है polyethylene से। सो यहाँ पे आपको याद रखना है। सो इन केस ऑफ aerosol, gasket is made from bunayan rubber or neoprene rubber or, you know, butyl rubber। So in case of aerosol, spring is made from a stainless steel. Mounting cap or ferrula is made from a aluminum or brass. Condensed spray valve. Housing or wall body is made from a nylon or durline. Deep tube is made from a polyethylene or polypropylene। तो actuator क्या होता है? What is the actuator? It is nothing but to ensure that to ensure that accurate product must be delivered in a proper and desired form। So that is the role of actuator। Actuator का role क्या होता है? To ensure that to ensure that the product must be delivered in an accurate amount, to deliver accurate amount of product at a desired site। Now there are two type of actuator, है ना। यहाँ पे दो टाइप के होते हैं। पहला होता है आपका स्प्रे एक्चुएटर एंड दूसरा होता है फोम एक्चुएटर। Okay, there are two type of actuator, spray actuator। So for a topical product, ये इसको यूज होता है topical product of antiseptic, local anesthetic, है ना। So it will produce a spray, है ना। ये spray produce करेगा, it will dispense the product in the form of spray actuator। दूसरा होता है foam actuator। So foam actuator will dispense the product in the form of foam, है ना। solid stream actuators एक तीसरा होता है। So that is for dispensing of semi solid product like ointment। ointment का भी aerosol होता है to dispense a solid stream, and special application actuators are also available। These are the type of actuators, है ना। तो actuator का काम क्या होता है? To ensure the correct amount of product should be delivered at a proper site and desired form। That is the role of actuator। टाइप ऑफ एक्चुएटर जैसे आपका होता है ना, स्प्रे एक्चुएटर, फोम एक्चुएटर, देन सॉलिड स्टीम एक्चुएटर, देन, है ना, स्पेशल पर्पस एक्चुएटर। मीटर डोज इनहेलर, मीटर डोज इनहेलर क्या होता है? सो मीटर डोज इनहेलर नोन एज एमडीआईज, दे आर nothing but they are having meter dose one, they are having meter dose one for the accurate dosage delivery, for the accurate dosage delivery। एंड इनका डोज जो होता है वो कौन डिसाइड करता है? इसमें एक चेम्बर होता है, द कैपेसिटी ऑफ चेम्बर दैट विल डिसाइड द डोज। देन इसमें, है ना, अलग अलग टाइप होता है। RADS, that is a reservoir eros type of delivery system, consists of a 700 ml collapsible plastic bag into which aerosol can be injected and developed from meter dose air। In metering balls, they are capable of dispensing a potent medicament or drug based upon the principle of chamber, whose size will decide the medication। तो इसमें से जितना साइज का चैम्बर है उतना ही डोज डिस्पेंस होगा। These are limited in both size as well as accuracy। तो उनका accuracy होता है, accuracy of dosage is approximately 50 to 150 micron plus minus 10% micron। That is the capacity। Are you getting? समझ रहा है आपको? Are you getting or not?